Just wait. I'm going to the recording. Yeah. Yeah. Tell me. Yeah.
6 is B.
What you are seeing on the screen? Classroom, right?
Yes. Yes.
Okay. 6 is
B.
Bangladesh.
Yes.
Yeah. Then.
7 is D. Dhaka.
Hmm.
8 is B. Bangladesh.
Hmm.
9 is D. Dhaka.
Hmm.
10 is A.
10.
A.
Oh, this one is not correct. Cross. 10
Uh,
cross. Huh?
okay.
Then
11 is also 11 is A.
cross.
12 B.
12.
B. Bangladesh.
Yes.
13 is C.
Yes.
14 is also C.
So you have two wrongs, right? In MCQ, 10 and 11.
Yes. Yes.
So we are opening the worksheet now. 10 and 11, right? These two.
Yes.
Then you gave which one?
A.
You gave A.
Yes.
So you also gave 50 Newton for weight.
Yes.
The mass is given 50 kg.
Yes.
Here, right?
Yes.
What is the formula of weight?
Weight equals to mass into gravitational field strength.
So weight equals mass into gravitational field strength. Your mass is 50.
Yes.
And your G is how much?
G is not given there.
G is not given there, but it is on bathroom scales, right?
Yes.
So it's on Earth.
Yes. So it should be 10.
Yes. There is no bathroom in the Mars, right, or any other place.
Yes.
Yeah, they are also sometimes testing your common sense, huh? That the experience you have in your daily life, right? So this one is giving
500.
500 newtons. Is it clear?
Yes.
Now we are going to next one. This one, huh? This one is related to density. So which one you gave? Hmm? Abir, which one you gave for 11? For 11 you gave
A. A.
you gave a. So density of P, right? Density of P. They are saying both have the same mass, right? P and Q both have the same mass. So which one has more density? P or Q? If you have less volume but the mass remains same, then which one has more density? Abir? Hello, Abir. Abir. Abir, are you in online? Hello? Oh, you are disconnected. Okay. Abir, welcome back, Abir. Hello?
Sir, I got disconnected.
Yeah, you got disconnected. Why?
I am having some network issues today.
Okay, fine. Now, look, P and Q, they both have the same mass, right? I underlined.
Yes,
So, if you check out, if you observe that P has less volume, Q has more volume, right?
yes.
So, which one you think has more density, P or Q?
Uh, Q.
Q has more density. How come? If you have the same mass, like for example, this one has 1 kg
Yes,
and this one is also having 1 kg.
yes.
So, which one has more density? I gave you
Both are
example of
same.
uh,
Both are same.
density. I gave you example last class that you are having 1 kg iron block and you
Yes,
have 1 kg cotton, right?
yes,
So cotton has bigger volume, but iron has smaller volume.
yes,
So in iron, the density should be more, right? The molecules
yes,
are closer. That's why
yes,
the small volume, but that one has more small volume, but it has mass, too much mass, right?
yes,
So this one has more density. So here in liquid P, we have less volume, but the same mass of liquid Q. So this one have more density, right?
yes.
Liquid P. Now they are asking you, liquid Q has the density rho. If
Yes,
uh, liquid Q has more density, liquid Q has density of rho, then
yes,
what will be the density for liquid P?
yes,
It should be more, right?
yes,
More than Q, right?
yes,
So more than Q, rho by 3 is not giving you more than 3. It's giving 1/3.
yes.
So uh, which one do you think correct?
I'm not sure, sir. It should be either C or D.
It should be C or D. Then we have to calculate. So
Yes.
you are sure that it will not be A or B, of
Yes.
course, right? But
Yes.
you can understand it's likely to be C or
D.
D. Already
Yes.
you got row by 3, that you got some ideas that it should be one third of something or three times of something, right?
Yes.
So it's more likely to be C. Let's check. We can also calculate. It's more likely to be C, okay? The three times density because the height is three times, isn't it?
Yes.
Here the height is three times.
Three
From
times.
there you got this idea row by three, isn't it?
Yes. Yes.
So so it's more likely to be three times, not nine
Oh.
times.
Oh.
Now we are going for more, profound calculation or more profound conceptual discussion. From the formula we can do it. Okay, can we do it from the formula?
Yes.
Yeah, our formula is giving us rho equals m by v, right?
Yes.
This one they give. So for liquid P, we are thinking it is rho P by Vp. Okay, m is same for both. Huh?
Okay.
For both P and Q, m is same,
Yes.
right?
Yes.
That's why in both cases, we are using m. Okay.
Yes.
Now look, we are having here for Q, it's rho Q, and it is m by VQ, right?
Yes.
For both of them, they are saying identical beakers.
Yes.
If they are identical beakers, that means they have same cross-sectional area, right?
Yes.
And from there we can find it is cylindrical shape object, right?
Yes.
For cylindrical shape object, we have the formula AH, right?
Yes.
For the volume, H, right?
Yes.
And for cylindrical object here also, for liquid Q, we are having BQ. We are having BQ this way.
Or what is age?
Yeah,
Area into height.
area into height. Cross-sectional area multiplied by height. And here we are getting the height 3h, right?
Yes.
Volume formula you know, right?
Yes.
Area multiplied by height we can write because it is cylindrical shaped object.
Yes.
For both of them identical, that's why both area is same, right?
Yes.
Now if we are putting this value in these equations, we are writing here, we are going to find density of liquid P, right?
Yes.
That means we are going to find rho P. So here we are writing rho P by rho Q. We are taking the ratio of these two equations we got, right?
Yes.
Here we are getting m by what?
And by VP.
Vp, right?
Yes.
So then Vp means AH.
Yes.
Can you write AH?
Yes.
So we are writing here AH. Then we can write also m by,
M M by A into 3H.
that means 3AH. We can write.
Yes.
Now from our all these equations we are having m cut, this m cut, AH cut, this AH cut, right?
Yes.
And we are going to find rho P, isn't it?
Yes.
And we have rho Q, uh,
1 by 3.
and these three will come up, right?
Yes.
Okay, it is 1 by 3, 1 by 1 by 3, then we are getting
To the power minus
reverse.
1.
Yeah, it's reverse, right?
Yes.
3. And rho
Yes.
Q means rho.
Yes.
Rho Q, for for Q, they gave the density rho.
Yes.
So we can replace rho Q as rho.
Yes.
So here we are getting the density of P, right?
Yes.
Rho P, 3 rho. So clear this one?
Yes. Yes.
Thank you for your understanding. Now we are going to structured part, right?
Yes.
Can we go to structured part?
Yes. Yes.
Yes, so we are going to structured part. Here, calculate the volume of water in the tank when it is full.
Yes.
So this one you got 6.5.
Yes.
How you got 6.5? Your density is given, right?
Yes.
Your
1000.
the combined mass of the tractor and the tank is 4100 kg when the tank is empty, and 6500 kg when the tank is full of water. So how much is the mass of water? Mass of water, how much? Hmm? Abir?
We should minus
Yes.
6500 minus 4100.
So if you minus, then how much it comes? Can you check?
2400.
Is it 2400 for you, or you got different?
No, sir. 2400.
It's 2400, right?
Yes.
Mass. Then volume comes how much? Your formula of
Uh,
volume is
M by P.
m by rho.
Yes, yes.
So m is here 12400.
So volume is 2.4.
Yeah, 2.4, right?
Yes.
So you got how much?
I wrote 6.5.
So you should do the working. Yeah, you subtract here.
Yes.
Do the working again. Do it, huh? Then tell me you are done.
Yes. Yes, sir. Done.
Okay, then the next question, what you wrote? You did not write anything.
No, I couldn't solve it.
Okay, so this one, two, right?
Yes.
Question two, we did not attempt A1, 2, you did not attempt.
No.
Can you read the question?
A force applied to a solid object may cause it to accelerate so that its velocity changes. State two other properties. Sir, the screen is gone.
Okay, now it's working.
Yes.
Okay,
State
now
two
continue.
other state two other properties of the object which may change when a force is applied.
So the force can accelerate,
Yes.
right?
Yes.
So that its velocity changes.
Yes.
Then force can change also direction.
Yes.
Okay, force can change the shape. Force can change the size.
So
Can
which
you
one should I
remember?
write, sir?
Can you remember we discussed that?
Yes. Yes.
So
Now I remember.
you write any two, huh? Any two you can write. Force can change the direction. Force can stop the object. Force can change the shape of the object.
Yes, sir. Done.
Weight, B, weight you got correctly. Three, rho equals m by v. Three, huh?
Yes.
You are asked to find the density, right?
Yes.
Okay, so can you read this question?
Figure 3.1 shows a painter standing on a wooden plank directly above the right hand support. The plank has length 3.6, width 0.35, and thickness 0.025. At the gravitational field strength G is 10 Newton per kg and the mass of the plank is 23 kg. Calculate
So
the density of the wood.
for getting the density, you need mass and volume, right?
Yes,
You found the volume
yes,
by multiplying all these three dimensions, right?
yes,
So 3.6 uh, into 0.35 into 0.025. Mass is 23, right?
yes,
23 kg. So you are getting 730 kg per meter cube.
Yes.
Good. Clear? So
Yes.
it is easy, right?
Yes.
This worksheet was easy. Only little bit problem you had.
Yes.
So done, huh? This worksheet is done.
Yes.
Only you got the corrected one, right?
Yes.
So when I will get the corrected one?
Uh, Today, inshallah.
Today, inshallah. Very good. So our topic 4 is done and its worksheet also done. Today we will do topic 5.
Yes.
Topic 5 name, do you know?
Uh, Force.
Turning effect of forces.
Yes. Yes. Turning the force.
Turning effect of forces we can find uh, here, right? You got the
Yes.
notes.
Yes.
The name of the topic is turning effect of forces. Can you read the learning outcomes loudly?
Uh, Learning outcomes candidate should be able to describe the movement of a force in terms of its turning effect and relate this to everyday examples. State the principle of movement for a body in equilibrium. Define movement of a force and recall and use the formula moment equals to force into perpendicular distance from the pivot and the principle of moments. Describe how to verify the principle of moments. Describe how to determine the position of the center of mass of a plane lamina. Describe qualitatively the effect of position of center of mass on the stability of simple objects.
Okay, so turning effect of forces, that means if you apply force on an object uh, which you can turn about a pivot,
Yes,
that object will show you turning effect of forces,
yes,
right?
yes,
There should be one pivot, and about the pivot you can turn the object. That object will show you turning effect of forces, and this
yes,
force, turning effect of force, is also known as moment.
yes,
And there is one principle of moments. When the object is turning, there will be clockwise or anti-clockwise rotation, right?
yes,
And if the object is not rotating, if it is balanced, then we can say the object has the moment balanced.
yes,
Clockwise and anti-clockwise moment are equal,
yes,
right? That's why the
yes,
object is in equilibrium. Also, there is another another condition, that is the opposite forces are working in the object. They should be also equal.
yes,
If the object is in equilibrium, then the forces should be equal, the opposite forces, and the opposite moment should be also equal in equilibrium condition. And from the formula, we can calculate moment. Moment equals force, the force we are applying, that force multiplied perpendicular distance from the pivot. Perpendicular distance from the pivot.
yes,
So it's very important that we are taking perpendicular distance from the pivot. It's not any distance,
Yes.
okay? From not from anywhere. It's from the pivot and it should be perpendicular,
Yes.
right? The distance
Yes.
should be perpendicular. Then we have described how to verify the principle of moments. Already you got what is principle of moments. Then we can verify it by numerical examples, real life examples, right?
Yes.
Then we have described how to determine the position of the center of mass of a plane lamina. You know, lamina is an irregular shaped object, and if you want to make the center of mass of it, then there are some steps to determine. Okay, using the string hole, we can make the position of the center of mass. Okay, we will show you here. And describe qualitatively the effect of the position of center of mass on the stability of simple objects. Yes, if there is change in stability, there will be, you see, uh, the effect of the position of the center of mass on the stability of simple objects. If the center mass is lowered, then we are getting the object more stable. If the base area is bigger, then we find the objects uh, likely to be more stable, right? If the base area is more.
Yes.
Now we will discuss all these things from the notes. Just I gave you brief idea for the learning outcomes, overall idea. We have here turning effect, right?
Yes.
Here we are pressing the handle of the range. This is known as range, or this is known as uh, there is another name, right? Spanner.
Oh, yes.
Spanner. If we are pushing it, the handle of the spanner down, then the screw will undo, right?
Yes.
Will have the turning effect. Okay, and you see it is pivot, and the spanner is giving you too much long hand. The
Yes.
more long hand we are getting, the more distance from the pivot, right?
Yes.
If you are getting more distance, then you are getting greater moment. You can open this screw easily. If
Yes.
your distance is smaller, like here, then it's very tough for you to open, right?
Yes.
So here we are applying the formula of moment to understand problems, right?
Yes.
Okay, now examples of turning effect of force. Can you read it?
A person pushing a swing will make the swing rotate about its pivot. The worker applies a force to a spanner to rotate a nut. A person removes a bottle's cork by pushing down the bottle's, bottle's opener lever. A force is applied to a doorknob and the door swings open about its hinge. A driver can turn a steering wheel by applying a force on its ring.
So here we gave five examples, right?
Yes,
Where to use the turning effect of force. So
yes,
this one, you see here some daily life examples, right?
yes,
We are having some daily life examples, everyday examples. So you understood what is turning effect, and you also got daily life examples. Our
Yes.
first learning outcome is over, right?
Yes.
Now moment of a force and its formula. hmm, moment moment of a force and its formula. We got this formula, right? We are using the symbol r, small r, for the moment, and force into distance, perpendicular distance from the pivot, right?
Yes.
So here we have the pivot and the force applied here, perpendicular distance. We can calculate the moment. If you know the values, you can get it, right?
Yes.
Here we have one question. Okay, here we have one question that find the moment created by the stone. Calculate weight of the metal block. So can you do it?
Yes.
First, you find moment created by the object, moment created by the stone. So here is the formula, right?
Yes.
R
F into V.
equals,
F into V.
you can see,
Yes, I can see.
okay. So if you can see, you write the values on your copy, write the values, huh?
Yes. So I got the answer.
What
23.2.
is your answer?
23.2.
How much?
23.2.
23.
Yes, point 2.
How you got 23?
Force is 24 and distance is 0.8 plus 4. So that
No, no. Your distance from the pivot. The
yes.
formula is giving you distance from the pivot. So
Oh,
the moment created by the stone should be only this part.
0.8. Only 0.8.
Yeah, this part only. So here
So the
this one
answer
is
is
wrong.
19.2.
19 point.
2.
Okay, how 19.2?
24 into 0.8.
Okay, you corrected it in your
Yes.
copy.
Yes.
Okay, it is 19.2. Then what is the unit?
Newton meter.
Very good. 19.2 Newton meter. Newton meter. Okay, we are done with this part. Then they are asking you to calculate the weight of the metal block. How will do it?
Weight equals to mass into gravitational velocity.
So this is not uh, related to that one you are saying. Weight equals mass
Oh,
into gravitational field strength. You are not given any mass even, right?
yes.
So how can find this weight? We already gave you some idea that pivot, you see on the pivot, these two objects are balanced, right?
Yes.
And we can say they are in equilibrium.
Yes.
If they are in equilibrium, that means their uh, opposite moments are equal, right?
Yes.
Here you see we are getting anti-clockwise moment for the stone, and for this metal block we are getting clockwise moment, right?
Yes.
As they are in equilibrium, we can say clockwise and anti-clockwise moment are equal.
Yes.
So we can say R1 equals R2, right?
Yes.
So R2 equals R1. Can you write this way?
Yes.
And R2 is, here we are getting this weight, that means it is the force, right?
Yes.
And we can write here force and distance from the pivot, how much for R2?
R4.
Right, sir. 4,
4.
very good. Very good. So we can write here 4, right?
Yes.
Then we have 19.2 for R1. Already we have
Yes.
19.2. Now we have left 19.2. I'm writing again. We have left here W, right?
Yes.
To find
19
W.
point 19.2 divided by 4.
Very good. Then what is the answer coming?
4.8.
4.4.8, right?
Yes.
And what should be the unit?
Newton.
Excellent. Weight is measured in
Newtons.
newtons. So this part is over, right?
Yes.
So how do you feel? You are learning, right?
Yes.
You are learning lots of things, mashallah. So these are the concept we got here. Now we are going to next. Equilibrium. Conditions for equilibrium. The one I said you, right?
Yes.
So can you read this part?
Equilibrium. A rigid body is considered to be in equilibrium if there is translational equilibrium and rotational equilibrium. A
Yeah,
body in
continue.
equilibrium, a body in equilibrium experiences no acceleration and will remain in equilibrium indefinitely unless it is disturbed by an external force, Newton's first law.
So this part is clear to you, right?
Yes,
A body in equilibrium means the body is in balanced, right?
yes,
Then we have no resultant force. We got it in Newton's first law. If there is no resultant force, that means there is no acceleration, right?
yes.
Okay. This one is the equilibrium condition we are going to discuss. First one is translational equilibrium. So can you continue here, the box one?
Translational equilibrium, the first condition for equilibrium is that there will be no resultant force. This means that the sum of all acting forces is zero.
So here in translational equilibrium, I told you about forces, right?
Yes,
Opposite forces are equal. So if opposite forces are equal, that means we are getting them, their sum is zero, right? You know,
yes,
if the forces are working opposite, they have different signs. One will be positive, another one will be negative, right?
negative. Yes,
So if it is upwards working 5 Newton, the downward force also will work 5 Newton minus, right?
yes,
So 5 minus 5, the resultant
zero.
force is coming 0.
Yes,
So this one is translational equilibrium. Is it clear?
yes, sir.
So can you continue here? Translational equilibrium.
Translational equilibrium is obtained when the resultant force or vector sum of all forces acting upon the rigid body is zero. In simpler terms, that means that forces to the left equals to forces pointing to the right, and the forces pointing up is equals to forces pointing down.
Okay, so if the forces working from left, there should be some forces pointing to the right.
Yes,
Okay, in this equilibrium condition, the same force. Then we have rotational equilibrium, right?
Yes.
Afterwards, so rotational equilibrium is related to rotation or turning of the object, which is related to moments, right?
Yes.
Can you read this part? Rotational equilibrium.
Rotational equilibrium is obtained when the algebraic sum of the torque is zero. The sum of the torque must equal zero.
So here we got, uh, look here, F1 D1, right? And
Yes.
F2 D2 as the moment. If one moment is clockwise, this one is anti-clockwise, and this one is clockwise. So they are in opposite direction, right? If the
Yes.
direction is opposite, then one will be negative of other.
Yes.
Is it clear?
Yes, sir.
So if one is F1 D1, then another one is minus is equal to minus F2 D2. That means if you do them plus, they will be zero, right?
Yes.
You sum up them, then it will be zero. So this one is saying that our moments should be in in equilibrium condition. The clockwise moment and anti-clockwise moment should be equal.
Yes.
Look, can you uh, can you read this part? Here we are giving a more organized, organized description of principle of movement. Can you read, please?
However, it can also be interpreted as the principle of movement states that for a body to be in rotational equilibrium, the sum of clockwise moments torpedo about any point which act as a pivot must be equal to the sum of anti-clockwise moments about the same point.
Okay, so you understood it, right?
Yes.
The sum of clockwise torques. Torques means movement, right? Sum of
Yes.
clockwise moments equals sum of anti-clockwise moments. Look, here we got uh, one senior person and one small girl. So they are staying at different distances, right?
Yes.
Uh, the person is very close to the pivot, and he is making the moment equal to the moment the girl got. Equal but
Yes.
opposite. That's why he has to come forward, right? As his
Yes.
weight is more, there will be more moment if he is going back.
Yes.
But if he is very close or his distance is small, his weight and distance multiplication, it will be equal to the distance times weight of the girl, right?
Yes.
Is it clear?
Yes, sir.
So if it is clear, you should memorize this principle of movements. You should memorize. Okay, can you memorize this? Sum of clockwise moments about the point must equal to the sum of anti-clockwise moments.
Yes.
Is it clear?
Yes, sir.
Okay, center of gravity. What is center of gravity? We are going to understand that one. Center of gravity is the point where all the masses of the object is staying. Do you understand?
Yes, sir.
There is a place in all the objects, every objects, according to their shape, according to their weight. Okay, so that weight is or that mass is concentrated at a small point, right?
Yes.
A small point on the object. That point is called center of gravity. Okay, can
Yes,
you
sir.
read this from definition?
Definition: the center of a mass of a body of matter is an imaginary point at which the entire mass of the body seems to act.
Okay, so here they are saying body, right? The center of mass of a body of matter.
Yes.
Uh, Here we can take any object, right?
Yes.
And we can find the center of mass. Uh, there is one technique you can go by, you know, the center of gravity of a body of matter is an imaginary point at which the center of weight of the body seems to act. So look, uh, they said once they said mass, once they said weight, right?
Yes.
So when they said mass, enter mass, that time they said center of mass. Is it clear?
Yes, sir.
And when they use center of gravity, then they were used weight. Okay.
Yes.
Can you please read these 3 points?
When a body is in a uniform gravitational field, its center of gravity is also its center of mass. The location of a body's center of gravity may coincide with the geometrical center of the body, especially in a symmetrical shaped body composed of homogeneous material. For hollow bodies or irregular shaped objects, the center of gravity or center of mass may occur in a space at a point external to the physical material. The center of gravity can lie outside the object, for example, in center of a tennis ball or between the legs of a chair.
Okay. You
Yes,
got here 3 examples. You understand it?
yes.
Okay. Note. Can you read the note?
Although the term center of gravity is widely used, the same imaginary point in a body may also be called the center of mass, since weight and mass are proportional in a uniform gravitational field. Because the center of mass does not require a gravitational field, many uh, drawing that
Physicist.
many physicists prefer the term center of mass to center of gravity. Example: the center of mass of an uniform rod is the center of the rod.
Okay, this one you understand. If the object is uniform, then that time the center of mass should be in the center, right?
Yes.
It's easier to understand. Then we are going to next part. This one is for regular shaped objects. Okay, so here we can easily find the center of mass at the middle of the object, right?
Yes.
But the objects which do not have any shape, those we can also find the center of gravity. Can you read this?
Which one, sir?
Self-assessment.
For self-test question: is the center of gravity of an object the same whether it is placed near the surface of the earth or near to the surface of the moon?
Uh,
Answer: yes. The center of gravity of an object does not depend on the strength of the gravitational force on Earth. The position of center of gravity is only dependent on distribution of mass within the object.
so is it clear?
Yes, sir.
Okay, then continue here. Still, we are not getting any irregular shaped object. That's why it's very easier to understand where is center of mass. But if you have irregular shaped object like this one, this is called lamina. Okay, then how to get the center of mass? We showed here the technique. Okay, first you make three holes from 3 points of the paper. It is a hard paper, thick paper. Then you hang the lamina from the first point from the top. Okay,
Sir, I'm not understanding.
okay, very good. Thank you for your response that you are not understanding and you are saying that you are not understanding. Look, at the beginning we are given this one, only the cardboard, okay?
Yes,
And this is irregular shaped. That's why we cannot take here center of mass directly. We have to use this plumb line, okay? We have to use this plumb line. Plumb line means there is a string and at the end there is some mass uh, fixed over there so that it can be straight, right?
yes,
This one, the string one, the string is very straight here because of this mass, right?
yes,
And it is hang from a hole anywhere. We can take three holes randomly, and the first hole we are using to hang the lamina so that it can easily freely move, right?
yes,
The lamina can freely move and it is fixed in a place. There we will get one line, plumb line. That one we have to draw with a ruler, okay? Across this string we have to draw what? One
line.
straight line. Yeah, one straight line.
Yes,
Same way, you see here we got the straight line, and the same way we will hang from other hole. Okay,
yes,
it was previously A, now we are hanging from B.
yes,
Okay, so when we are hanging from it again, we are making the line. Okay, again we are
then
drawing.
what is that red line?
Yeah, red line is the first line we drew
Oh,
with the pencil or with the color pen. You can draw it first.
yes,
The position of the string, that is called
yes,
plumb line.
yes,
You already did that for A. Now you will do the same thing for B.
yes. Oh,
And
yes,
you
I understand.
see A and B, they are the line we got here across A and B, they are cutting each other, right? At a
Yes,
point. And we will see if we hang from the third point C again, then we'll get they that line also intersecting the center already we got.
yes.
So this way we can get the center of gravity of a plane lamina.
Oh,
Okay,
yes,
is it clear?
yes, sir.
That one we got here in the learning outcomes. Look, at the beginning we got the learning outcomes. Here they told us. Here you see, describe how to determine the position of the center of mass of a plane lamina. So you got it right.
Yes, yes, sir.
Then we got all this that principal moments, right? The formula, everything we
Yes,
discussed, right? How to
yes,
verify principle of moments. We gave example, huh?
yes, sir.
Here we got principle of moments, huh? Clockwise and anti-clockwise moments are equal. Also here we got principle of moment. Clockwise and anti-clockwise moment are equal. So all these are done, right? You are clear about
Yes,
them.
sir.
Now the last
Yes.
last thing is stability. Look, we showed here you three positions of the same object, right?
Yes.
And you see the first one, its base area is bigger, right? That's why it is very
Yes.
much stable. And when we will find the center of mass, then we will see that the center of mass is lower here, in a lower point,
Yes.
because its lower side is, there is more wide, right?
Yes.
More particles are here. So there will be center of mass somewhere in this place. So it has it has bigger base area and lower center of mass. That's why it is more stable. Got it?
Yes, sir.
But this one, you see, this one is having smaller base area, and the center of mass will be upper place, not in lower place. That's why it is becoming unstable equilibrium, right?
Yes.
Anytime it can be falling down. Is it clear?
Yes, sir.
So stable and unstable you understood, right? Now can
Yes.
you read this stability?
Stability refers to the ability of a body to restore to its original static equilibrium after it has been slightly displaced. A body in equilibrium experiences neither linear acceleration nor turning effect, and unless disturbed by an outside force, it will continue in a condition indefinitely. Newton's first law.
Okay, so is it clear?
Yes, sir.
Now, one we have neutral equilibrium. We will have some idea here. Already we discussed stable equilibrium, unstable equilibrium, right?
Yes.
And if you read, then you will understand it more. Can you read stable and unstable equilibrium?
Stable equilibrium. Equilibrium said to be stable is small externally induced displacement from the state produce forces of torque that tend to oppose the displacement and return the body to its original equilibrium. Example, a hanging pendulum or a wick lying on a level plane.
Okay,
Unstable equilibrium.
okay. Wait. Here, if we want to just displace it by holding this
Yes.
point, right? If you
Yes.
push or pull a little bit, then you will see that it will come to its original position again. It will come back, right?
Yes.
That's why it is stable equilibrium. But this one,
Hmm.
if you just
It will
push
fall.
little bit you push, then it will fall down, right?
Yes. Yes.
Okay. So that's why it is unstable equilibrium. That one is said here. Can you continue unstable equilibrium?
An unstable equilibrium is said to be unstable if the least departures produce force of torque that tend to increase the displacement. Example, a rule standing on its end or a ball standing on the top of an inverted ball.
So is it clear?
Yes, sir.
Now neutral equilibrium. Can you read?
An equilibrium is said to be neutral if small externally induced displacements from that state does not produce any unbalanced forces or torques that tend to oppose or aggravate the displacement, and the body remains in its new equilibrium. Example, a pencil lying on a level surface.
Yes. So if you keep this one is like they are saying the body remains in its new equilibrium, right?
Yes.
So this one is clear to you?
No, sir. Can you explain again?
Yeah. So here they are saying an equilibrium is said to be neutral if small externally induced displacement from that state does not produce any unbalanced forces or torques that tend to oppose or aggravate the displacement, and the body remains in its new equilibrium. So neutral equilibrium is like it's not toppling, or it's not coming to its original position again. If you are just rolling it, then it will have new position, but it's not toppling, right?
Yes.
It's the similar, but not in original position. It's new position. So that's why it is called neutral equilibrium. Is it fine? The explanation you understand?
Yes, sir. Now I understand.
Okay, clear. Now we have here the relationship or the comparison between the summary of different states of equilibrium. You already understood it, right?
Yes.
If the base area is large, then it is more stable. Then height of CG, that is center of gravity, if it is lower, lower the center of gravity, then it is more stable, right?
Yes.
Then if it is smaller base area, then it is unstable. If the center of gravity is higher place, then it is unstable, right?
Yes.
And we also understand that slight displacement return to original position and it is toppling over. For the neutral one line of contact or points of contact with surface. That means always it's in contact with the surface, right? The same line, similar way. Stay in new position. It's coming to a new position, right?
Yes.
But it's not unstable. Okay, then can you please read these two highlighted points? Stable
Stable body.
bodies.
Stable bodies tend to have low center of gravity, wide base area. Hence, the stability of an object can be improved by lowering its center of gravity, increasing the base area.
So it is clear, right?
Yes, sir.
So done. This topic is done. You can solve the worksheet, right?
Yes.
Now I'm uploading the worksheet. Then you try it, huh?
Yes.
Try it, huh? I'm uploading both the notes and worksheet now.
Worksheet.
Yeah. Then you try it, huh? Just
Yes,
after
sir.
5 minutes, you can start trying.
Yes.
Thank you, huh?
Yes. Allah Hafiz, sir.
Allah Hafiz. Assalamu alaikum.